We have another kind of frame structure that's on the ground, supported by four footings with the load acting on one corner. So again, we have a bunch of points to identify. I used A as the origin, which should be A, and then define all the other points with respect to it. And each, basically, our dimensions are all given in terms of A, which we could either decide with feet or meters or yards or whatever we want as a length. And then we have, I then defined a point, um, a point I here. So sorry. All of these forces, we're told at all of these junctures, just have a component out of, away from the perpendicular to the ground. So I just called that the z direction. So all of them. So we have eight forces again. I think 1, 2, 3, 4, 5, 6, 7, 8. Eight forces perpendicular to the ground at each of these junctions and at the where the footings contact the planks. And then I defined another point P, which is where the external load acts. And actually, point P is actually the same as point A. So I should write that in here. So P equals A. I just used a different notation for it so we can separate out the internal load at A and the external load acting at A. So then again, I'm going to assume we're going to have some moments so that we have enough unknowns to satisfy all of our equations. And again, I assumed that there were just bending moments at the joints. And again, it's going to turn out that that all of these things are all these moments are zero. But it's hard to know that they suggested that we use that in the book, but we assume that in the book, but then we'd have 12 equations, and well, we'd only have we would wind up with we could have 9 equations and 8 unknowns. So one of them must be trivially satisfied, but it's hard to know that from the beginning. So I just included a bunch of these extra unknowns, which is pretty clear from when you start doing the analysis that these are all going to drop out and be zero. So the sets I took, I looked at free body diagrams of F, G, H, E, P, which those load, that's the entire structure. Loads acting at F, G, H, E, and P. So these are the footings and the external load. Then I looked at member B, G, C, and then member D, H, C. And again, remembering that we need to make sure that these internal loads have equal and opposite signs. And then member D, E, A. And again, remembering the internal load at D needs to have the equal and opposite signs. And so we can sum all of our forces over all of these, and then all of these, all of these, and all of these, and we'll get 4 equations there. And then we'll get another 8 non-trivial equations here. So we'll have 12 equations and 12 unknowns. And like I said, it's pretty quick. You pretty quickly see that these things are zero, and then things kind of fall out. But I just let the computer solve it much easier that way. So we're asked for the forces at the footings, and the force at footing E is minus P over 5, which means that it is in the in the upwards direction. So basically, or the force on it is in the negative direction, but then that means that the footing made to be pulling down on it. So if it's just especially being supported by the footings and there's nothing holding it to the footings, then it would actually lift off the footing and lift off of this footing too. Well, it's hard to tell. It would lift off one of them, and then we'd have to redo the analysis, assuming one of these was zero, and see if this one, the other one, is also negative. And then we'd have to redo the analysis, seeing that both of them are zero, and what we get. But again, we're going to assume that the footings are actually holding the planks down. So it's okay to have minus P over 5, and then we have 8P over 5, so we actually have a larger load at footing F than the applied load, and not just because of these boards we're neglecting the weight of the boards. And so then again, we have a force pulling the board up off of G, off of footing G, and a force of 2/5 of the applied load acting at H. So again, it's a little hard to justify this. You can kind of see what's happening a bit. That we have, if we were to put a load there, it would kind of want to prop things up off of some of these footings.